All right. This whole unit is on systems of equations and different ways to solve systems of equations. Okay? A system of equations, all it is two equations that we are comparing to each other. Okay, so that's all we mean by a system of equations, is that we are comparing two different equations to one another. Okay? The solution to a system of equations is the point or points, okay, where the two equations intersect. Okay, so between this whole unit, we're going to be talking about 3 different ways to solve systems of equations. Okay, and anytime that we're looking for the solution to a system, that means that we are trying to find out where they intersect. Does that make sense? So far, so good? All right, so this is what happens when our lines intersect. Okay, they intersect. We end up with one solution. Okay, and that solution is going to be x comma y, or whatever point it is where they intersect. Okay, if we graph two lines and they're parallel, do they intersect ever? So they don't intersect. It's going to be no solution. Very good. Okay. One thing I do need to bring up, some of us are writing our zeros like this. Okay, this is not a zero. Okay, this means no solution. Okay, so your 0 is just a 0. If you put a line through it like this, it means no solution. Okay, so if you mean 0, just write 0, but if you mean no solution, then you can put a line through it. Does that make sense? Okay, all right. So now you're going to get one that looks like this when my two lines are right on top of each other, or we have identical lines. How many places, okay, if this is two different lines right here, how many different places do those intersect? Infinitely many solutions. All right, so let's do some of these. And today, the way that we're going to do these is by graphing. Okay, so we have to remember a little bit that if we want to graph these, our equations, we want them in slope, intercept form. What does slope intercept form look like again? Y equals mx plus b. What does my b stand for? Yeah, my b is going to be my y-intercept, or my starting point, right? And my m is going to stand for what? My slope. So that's my rise and my run. So that's going to tell me what I'm doing. Max, writing this stuff down will help you stay awake, buddy. I know it's hard on a Monday morning after break. Okay? All right, so if I'm looking at y equals x minus 8, what's my starting point? Negative 8. 3, 4, 5, 6, 7, 8. So we're starting at negative 8. And then what's in front of my x? A 1. Yep, it's an imaginary 1. So that tells me to do what? 1 over 1. So remember, you're going up 1, and then you have to go to the right one. You don't go to the left, so up 1 over 1, up 1 over 1. be a little bit more important this chapter to draw your lines fairly straight. Okay, you might want to use like a straight edge, whether it be just the side of a notebook or something like that. Okay? Alright, I'm going to do this guy in a different color. My starting point. 1. So we're going to start at 1. And now, my slope is -2, so that tells me to down to number 1. Which way do I go over? Go no to the right. Okay? So you're going down 2, and then you got to go to the right 1. Okay, because you want it to go downhill. If you went to the left 1, you would notice that your line doesn't go downhill. Plus 1. That's my starting point right there. Okay, does that make sense? Alright, so then you're not done. Okay, I know that we graphed our 2 lines, but we have to state what our solution is. Because they want to know what our solution is. What we do is we write our point where it intersects. Where does this guy intersect? 3, -1, 2, 3, 4, 5. Okay, so you see why your lines have to be kind of straight on these to see where they intersect? Okay, so my solution that we're looking for is that 3, -5. So far, so good? Alright, so over here, my starting point is 9. 4, 5, 6, 7, 8, 9. And then what do I do? Okay, but careful, this tells us to go up 1 over 2. So I can go up 1 and over 2. Now, if I run out of space, if I go down 1, where would I have to go? To the left, because I would go opposite. So down 1, and I can go to the left 2. Okay, so bottom 1, where am I starting? Starting at 6. 6, and it tells me to down 1 over 1. Down 1 over 1. And if your lines are straight, where do these intersect? Okay, so if you extend your line, they do intersect, right? Because some of us, if we just connect our dots and we leave them there, you're going to be like, oh, those don't intersect. But we have to extend our lines until they do intersect. Right? All right. We need to look at, all right, so let's look at number 3. What's wrong with number 3? It's not in slope-intercept form. We've got to get both of them in slope-intercept form. So my top equation, how am I going to get it in slope-intercept form?
Add 3x to both sides.
Add 3x. So my top equation is y equals 3x plus 8. So my starting point is?
8.
And I do what? Up 3 over 1, and if I don't have any room, I can go down 3 into the left one. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then okay, you can always check your line by being like, okay, is my slope positive or negative? It's a positive 3, and if I look at my line, does it go uphill? Alright, so my bottom line, what do I have to do? Add x to both sides. So y equals x minus 2. Where do I start? Negative 2, and I go up 1 over 1. Uh-oh. And my line is if my lines would have been straight, where should my lines have intersected? Okay, so you might have to extend your lines a little bit further to find that intersection point. That makes sense? Is this super easy? Well, it's a lot of review, right? It's a lot of putting everything together. Okay, we have to be able to get our lines into y equals. That's number one important part, right? And number two important part is we have to remember how to graph, right?
Yeah.
No me out here. All right, so